All right. What I want to do is just kind of start us off all in the same foot here. Talk about functions. You know, we'll be doing the calculus of functions, talking about different things we can do with functions. But what do I mean by a function? Well, usually when we think of a function, we think of an equation. It can be represented in different ways, but say I've got a function f of x equals x squared plus 2x plus 5. It's just an equation that sets up a relationship, right? And it's a relationship where each x value that we plug in will give us one function value, or f of x value. And so this is just our usual notation, and it just sets up a relationship. Now we can do different things. We can do that. What does that mean? X equals 3. So that's my input value, if you want to think of it. So I'm going to input the 3, and I'm not starting off too bad, am I? Okay. So you got 9 plus 6 plus 5. So you got 20. Okay. And so when the input value is 3, the output value is 20. Now, of course, that means a lot of things, right? One thing it means, if we go to the graph then, what does it mean? Well, this is the x value. What is this? That's the y value, okay? So the function value is the y value too. So it's just a relationship between x and its function value, or x and y, if we think of the x, y axes. Of course, we can set up, we can input not just numbers, we can input expressions as well. What does this mean? Same thing, right? Except now we're going to input the quantity x minus 2 wherever we see the x, right? And so that, but we compute it basically the same way. It's just, we're just not going to get just a number here, because if I plug in x minus 2 for x, I got x minus 2 squared. And then I plug in x minus 2 for x here, I've got 2 times x minus 2, and then don't forget your plus 5 there. And what can I do with that? Well, yeah, we can multiply it out and combine terms and things like that. So here, x minus 2 squared, I just like to think of it as x minus 2 twice, and you got a FOIL, however you want to get that, but it's x squared minus a 2x minus another 2x plus 4. Does that sound okay? And this would be 2x minus 4 plus 5. And so that's x squared. What do I got? Well, got a 2x cancel out. 4 cancel out. So it's x squared minus 2x plus 5. So we get a little different expression there. And that's as far as you can take it, because it's just wanting what is the function value when x is x minus 2, and that's what it is. Okay? Not too bad, right? Now, we mentioned it back when we did this one, but there is a connection then. Another way we can represent functions is by the graph, right? If I take a look at the graph here of this one, somebody can tell me what shape that is at least. What shape is that? Well, you got an x squared equation, got a parabola, right? Opening up parabola, and that's you can do some analyzing on it if you want to, but that's where our handy dandy graphing calculator will come in. I know the y-intercept is going to be 5, so let me go ahead and put that here. I think the vertex, it's going to be a -1, so anyway, let's just look at it. Do it the easy way here. That's what these are for, okay? Okay, so x squared plus 2x plus 5. Yeah, all right, so the vertex comes in somewhere along in here. Something like that. I think this bottoms out right at 4 and -1. That's where that point is. All right. So that's another way functions Of course, as we know, what test do we have for the functions here? Vertical line test. Passes the vertical line test, it's a function. You won't have, these won't be, functions of x anyway. You know, that's not a function because it doesn't pass the vertical line test. It's got more than one point of intersection on a vertical line. So functions pass that vertical line test and all that. Comes from the definition. One x has exactly one y. But anyway, I was going to mention here domain and range. Sometimes they will ask about that. What do I mean by the domain? Domain is the set of what? Set of x's. Set of input values, which usually typically is our x's. And then the range is the set of outputs, whoops, which are typically our y's. Domain and range. Now, a lot of times from the equation, you can look at what your inputs are going to be. You know, there's sometimes going to be some restrictions on x, like if you have the square root of x. Since we're dealing with, since we're only dealing in real numbers for this class anyway, the domain there, the x values, well, you couldn't do a negative x, so the domain would be x anything greater than or equal to 0, no negatives, right? So there's sometimes restrictions. Are there any restrictions here? Can x be anything? X can be anything. And so you might say the domain for this function is all real numbers. Just to give you some other notations here, we could utilize our negative infinity, positive infinity notation, right? Any real number. Have you seen this one though? I don't know that they use this one too much right now, but the real numbers, all real numbers, can be represented with an R. Now the range, that's a little trickier. It's sometimes hard to tell from the function what the y values would be. But that's why the graph would come in handy here, wouldn't it? Looking at the graph here, what would be the range, which is, again, the y values. What y values do I have? You used here. The smallest designated range we could make. And I haven't done a real good job of lining that up, but that's supposed to be there. Doesn't the y value start at 4 and then go up? So it's 4 to infinity. If we use the interval notation. Or we could say the y's are greater than or equal to 4. So different ways of representing those. But they'll ask about domains and range a little bit throughout there. All right, so that's where they'll ask about these functions from a graph. Say we don't know the function, so that's why I've got on the handout there figure 1. Is any questions about this? All good? So far so good? Said I usually don't like to erase them, but to get it recorded, pretty much got to erase what I'm writing. All right, so figure 1 on the handout looks something like this. Starts here at 1. And yeah, the first thing I wanted to mention, they do this there in the homework, is this one's different in that it doesn't extend infinitely both ways. You know, our parabola before, you know, it went up infinitely. And so that meant, you know, our range was 4 to infinity. Well, this one, they have specified the domain. In other words, we're not going anywhere besides between 0 and 6 on the x-axis. You see what I'm saying? And that's designated because I've got the dots. So it's a start and a stop. That one doesn't have a start and a stop, right? Okay. This one does. So that's the first thing. So if this is our just calling it f, y equals f of x. What is the domain of f there? The d of f, okay. What's our domain? 0 to 6. Yeah, that's what we're just saying. We're not going anywhere in the x besides 0 to 6. And we are including the endpoints. I do have a point at 0. I do have a point at 6, x equals 6. And so I use the brackets. What's the range? Well, I didn't put it up here, but it goes from, that's 1. It looks like the high point highs out at 5. 1 to 5. Is that what y'all see? Okay. So the range is 1 to 5. So I wanted to do that because it's a little different than the first example I gave with the f of x parabola there. And also, I wanted to mention here, how would I do this one? If that's f, what's f of 4? How would I get that? Because I don't have any equation to plug it into. Well, I can look at the graph, though, can't I? That's just saying the x is 4, so I'd come here at x is 4 and see what I've got for the y value. Is that the top? Yep. It's the top point, isn't it? It's just when x is 4, the y value is 5, isn't it? Does that look right? Everybody okay with that? Okay. The other it's a 3. The other question here that they might ask, I think they might ask, it's a new book, so I'm not sure it asks, but I think it probably will ask this type of question. What are the x's where f of x equals 3? What does that mean? Well, this problem, I gave you the x, right? That was the x. What is this problem giving me? That's the y, okay. So I'm looking for the y value of 3, and so if I come up, here's 2, 3, all right? So if I come up at 3, and actually I didn't do a good job here because that doesn't that point, so if I come across at 3, I've got two points where the graph is 3, right? Function y is 3. It's this point and this point. So what x does that correspond to? Probably looks like about 1.5 maybe. Is that what y'all see? This x corresponds about 1.5. It's not at 1. At 1 it's just a little over 2, and at 2 it's so I'm thinking it's 1.5. So the x is 1.5, but it's definitely also 3 at x equals 6. So 1.5 and 6 is what I see. Is that okay? Is everybody with me there? Good? Okay. All right.